Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss Brillouin Zone. Let's begin. What is Brillouin Zone? That is a region bounded by Wagner-sized plane in reciprocal lattice. It's known as Brillouin Zone. Region bounded by the Wagner-sized plane in reciprocal lattice. Remember, Wagner-sized plane in reciprocal lattice. Let me consider in two dimension the reciprocal lattice points. In direct lattice points are the infinite array of points in space having same surroundings, but same lattice points we assume as the reciprocal lattice points. Each reciprocal lattice point corresponds to a parallel plane of line. These points are the reciprocal lattice points. According to the definition of Brillouin zone, that is the region bounded by Wagner-sized plane in reciprocal lattice. So, how to construct a Wagner-sized cell? First, we have to take in any one of that of reciprocal lattice point as a center. And join the nearby lattice points with it. Then draw the perpendicular bisectors taking that line. The perpendicular bisector of this line perpendicular bisector of that line and these perpendicular bisectors then join the perpendicular bisector of this line perpendicular bisector of that line then the region bounded by these perpendicular bisectors is the first Brillouin zone. This red line symbols, now I darken it, is the first Brillouin zone. First Brillouin zone. Next, anyone can draw that of perpendicular bisector of that line. Perpendicular bisector of that line perpendicular bisector this line perpendicular bisector of that line. Actually, these are the points, there will be the lattice points. Now, the region in between these sections which I darken are the second Brillouin zones. This is the first Brillouin zone. Picturized as red line. Next, this colored are the second Brillouin zone. Further, if we enlarge these points towards this, then joining this perpendicular bisector and the zones we obtained are known as the third Brillouin zone, and so on. In this way, the Brillouin zones are constructed by taking the Wagner's plane in that of reciprocal lattices. These are the reciprocal lattices. Let us construct the Brillouin zone mathematically by taking an example. Example, Brillouin zone for simple square lattice having side small a. Know that the primitive translational vector of that given lattice, the primitive translation vectors of simple square lattice is given by a vector is equal to a I cap and b vector is equal to b j cap, that is also is equal to a j cap, as a equal to b, that is the side of the lattice. Now, the relation between primitive translational vectors for direct lattice to the primitive translational vector for reciprocal lattice. So, the translational vectors of reciprocal lattice becomes the relation between translational vector of reciprocal lattice to direct lattice, as a vector is equal to 2 pi by a I cap and b vector is equal to 2 pi by a j cap. As we taken it in 2 dimension, we are just a b as I cap and j cap. Hence, the reciprocal lattice vector is given by, hence the reciprocal lattice vector g vector is given by, so g vector is equal to h a vector plus k b vector, whereas g vector is equal to, putting the value of a and b, so 2 pi by a as common, h I cap plus k j cap, where h and k are the integers, which represent the Miller indices, and k vector, let me introduce k vector, which is the wave vector, is equal to kx I cap ky j cap, the component of k vector. A new concept, that is Bragg's condition. The Bragg's condition we have explained in upcoming video lectures when we are discussing about the X-ray diffraction in crystals. In that session we just remember it, according to Bragg's condition, two k vector dot g vector plus g square is equal to 0, or 2 k vector as kx I cap ky j cap, that is dot product with g vector 2 pi a h I cap plus k j cap. So the dot product will be kx gx plus ky gy plus similarly g square as g vector dot g vector, it will be gx square plus gy square is equal to 0, or 2 as common kx. So the value of gx, that is 2 pi by a into h, 2 pi by a into h plus ky, value of gy, 2 pi by a into k, 2 pi by a into k plus value of gx, 2 pi by a square h square plus 2 pi by a square k square is equal to 0. Taking the common term, 2 is multiplied here, it will be 4 pi by a as common. In that of bracket we have h kx plus k ky is equal to these two terms to that side and taken common as 2 pi by a minus 2 pi by a square. Inside that bracket we have h square plus k square, or h kx plus k ky under the cancellation of 4 pi by a to 2 pi by a, you have minus of pi by a s square plus k square. That is a equation. This equation represents a family of straight lines in kx and ky plane, family of straight lines in kx and ky plane. Therefore, the intercepts of kx and ky are given as, therefore the intercepts of kx also represent a family of straight line, ky also represent a family of straight line. So the intercept of kx and ky are given by the equations. The intercepts of kx is represented by the equation minus pi by a h square plus k square divided by h. Next ky as minus pi by a h square plus k square divided by k. Now we have to choose the respective values, and by choosing the respective values we can construct the Brillouin zone for simple square lattice having side A. By taking all possible combinations of H and K. So here for Kx it represent family of straight lines, x intercepts and ky intercepts. We obtain the value of k vector. The possible combinations let we choose. For H is equal to plus minus 1 and k is equal to 0. Putting that value here, we have kx is equal to plus minus pi by a, whereas ky chosen arbitrarily is arbitrary. Next, as k is equal to plus minus a and h is equal to 0, when we choose for h is equal to 0 and k is equal to plus minus 1, at that of situation kx chosen arbitrarily, kx is arbitrary, and at that of case ky plus minus pi by a. That be a situation. The values of kx is equal to plus minus pi by a and ky is equal to plus minus pi by a. Means the graph of these 4 lines as pi by a minus pi by a in x section, plus pi by a minus pi by a in y sections. Another situations may occur as for h is equal to plus minus 1 and k is equal to plus minus 1. In that of situation, it will be 4 set of equations we can run. 4 set of equations like as when h is equal to 1 and k is equal to 1, so we have the situations as plus minus kx plus minus ky is equal to 2 pi by a, means 2 conditions as kx plus ky is equal to plus 2 pi by a, another one kx minus ky, it will be minus 2 pi by a. Another scenario when kx minus ky is equal to plus 2 pi by a and kx minus ky minus 2 pi by a, as h is equal to 1 and k is equal to 1, h is equal to minus 1 and k is equal to minus 1. If h is equal to 1 and k is equal to minus 1, h is equal to 1 and k is equal to k is equal to 1, h is equal to minus 1. These are the situations. In that way 4 kind of equations are drawn for 4 set of straight lines. Now These are the possible combinations for the values of S and K. By treating these values, we can draw the Brillouin zones. Look here, Kx is equal to minus pi by A, Ky is equal to plus minus pi by A. Now, the graph we have to plot these 4 lines as Kx is equal to plus pi by A, Kx is equal to minus pi by A, Ky is equal to plus pi by A, and Ky is equal to minus pi by A is plotted as the first Brillouin zone is produced by taking the origin at O. First Brillouin zone is produced. How we construct it? Let's see that a figure. In x axis Kx, in y axis that is Ky, origin. First Kx is equal to plus pi by A, at plus pi by A the plane is drawn. Next at minus pi by A another plane is drawn. For y, plus pi by A, minus pi by A, plus pi by A plane is drawn, minus pi by A plane is drawn. So within that we symbolize in red sections, we obtain first Brillouin zone. This is the first Brillouin zone. This is the first Brillouin zone. Next, these 4 equations represent 4 lines Kx plus Ky is equal to pi by A, and these lines are constructed taking as so these sections are referred as second Brillouin zone. When you draw in acquire exact measurements, then you can easily obtain the lines. So these lines second Brillouin zone. Second Brillouin zone. This is an example as we draw or construct the Brillouin zone for a simple square lattice of side A. In mathematical situations, family of straight lines are obtained in kx and ky, the intercepts of kx and ky, possible combinations. By taking the combinations, we draw the lines, and then first Brillouin zone and second Brillouin zones are obtained. So here, with the help of this video lecture, we understand the concept of a Brillouin zone. What is Brillouin zone? Now, how we construct in Brillouin zones in 2 dimensions. An example related to Brillouin zone. Brillouin zone for simple square lattice having side A. Mathematically, we construct the Brillouin zone. Brillouin zone is constructed mathematically. So, with this useful and informative notes, let me wind up this session. Thank you.